Today, we're going to discuss the benefits of software modularity and cohesion. Modularity and cohesion are key software engineering concepts that software engineers frequently misunderstand. Frequently, software developers know that modularity is good in some vague general sense, but they can't quantify the benefits. This lack of understanding leads to poor decisions when adding new functionality or fixing system bugs, often leading to the proverbial big ball of mud code base. And sometimes engineers don't know that modularity is what a good engineer does. Sometimes they feel like it's someone else's responsibility to tell them, like their manager or the software architect, and that they're simply responsible for implementing the task in front of them the fastest way they know how. So in this video, we try to provide some specific business reasons why adding modularity to your existing, growing, scaling code base is a good business decision. Because sometimes engineers know intuitively how to do a good job, but sometimes they can't explain it to business stakeholders. And in fact, one of the reasons I'm making this video is I try to clarify my own vision of what a good modular software code base is. So first, let's talk about complexity. One of the biggest problems in software engineering is managing complexity. And modularity is a tool for managing complexity. So when we talk about complexity, we're referring to a mature, growing code base with, let's say, 10 or more software developers. A young code base or a side project with a couple developers may benefit from modularity, but not as much as a bigger, more complex code base. Also, when we talk about complexity, we must manage complexity of both people and systems, right? People must work independently at maximum velocity without being slowed down by others. Systems, on the other hand, must be simple enough that a person, an engineer, can think about them without being overwhelmed. And complexity increases the cost of ownership of software because, first, engineers cannot move at maximum velocity due to coupling to other teams a part of the code base. And two, engineers cannot understand the code, which leads to slow development and more bugs. Often you hear people talk about, throwing more people at the problem. It may actually be bad because it may actually slow down the development. And this ties into managing the complexity of people. There's one specific anti-pattern I want to mention. It's the hero engineer anti-pattern. So oftentimes complex code bases have these hero developers who know the code base and become the go-to person for solving critical issues or implementing complex features. So the prevalence of such heroes may be a sign that your code base is too complex and that you must change things to scale your business. The hero engineer may actually be contributing to the problem because they could, one, maybe focusing on quick fixes rather than long-term scalable solutions. And two, since they're already familiar with the code base, they may think it's just fine as it is because, that's the way we've always done it, right? It may be to their benefit to keep things the way they are. All right, let's move on to definitions of modularity and cohesion. So modularity is the process of breaking up a complex system into smaller, independent, and interchangeable modules. Quick diagram, right? You got complex system, and then you break it up into some modules. So monolithic system, and then a modular system where things talk to each other maybe in some ways. Small enough means it's small enough to easily understand. Independent means that we can compile and test the module independently of all other modules. And I wanna talk about testing a bit more. Let's clear this. So you have a module. It can compile by itself. And then you have a test of this module, right? And this module may, may have some, test mocks. Now, suppose you wanted to test this module with another module. So you've got this test, and then let's switch color. You've got another module. So this test on the right, in order to, if this is the test you have, if you're always testing your module with another module, that is an integration test, right? You're not really testing your module by itself. So I would not say that this module on the right is fully independent, right? In order to deploy this module on the right, this blue module also has to be deployed with it. So this is something to watch out for. When you're testing, when your tests require that they be tested with another module, then your module is not fully independent. Just something to watch out for. All right, so we covered small enough, independent, and interchangeable. Interchangeable means we can substitute other implementations of module in our system. And as we saw in the diagram, that often happens during testing. Okay, cohesion. Cohesion refers to the degree in which functionality inside a module belongs together, right? And it's important for modularity because cohesion is actually the metric that we should be using for creating modules, with our goal being high cohesion. A good module has high cohesion, and any logical changes in that module should generally not leak to other modules, so they should be inside that module. So that means if you've got like a helper function module or something like that that just has random function, well, that module is not really a good module because it has low cohesion. All right, so now let's move on to the 6 business benefits of a modular code base. So these are some arguments you can use to talk to business folks in your organizations or perhaps other developers. So first, most important for developers, faster development and easier maintenance. So modularity increases engineering velocity, which from a business sense, lowers labor costs and reduces time to market. So since modules are cohesive, right, all the related logic is in one place and they're easier to understand because they're small, engineers will naturally focus their changes on the limited sets of modules when they're making, adding new features or fixing bugs, as opposed to wading through the whole code base and making little changes here and there. And since modules are independent and interchangeable, they're easier to test, right? And the diagram I showed earlier, in fact, I have it still up. Let's jump into it. So this diagram right here on the left, right? This is an independent module that is quick to test. It is fast to compile because it doesn't have any extra dependencies. So any new functionality, you add it and run this test, it's ready to sign off. You can finish your task and move on to the next task. As opposed to the right, if it has dependencies and this blue dependencies is broken at the time, then you're blocked, right? So we want the case on the left. Writing tests becomes faster and easier. All right. Second, risk reduction, right? A frequent occurrence in a complex code base is the change in one place introduces a bug in another seemingly unrelated functionality. And why does that happen? Because everything's together, everything's coupled. But because modules are cohesive and independent, a bug in one module is less likely to bring down the entire system. Now, theoretically, it's still possible, but it's much less likely. And also, since modules are more straightforward to test, they're less likely to have bugs in the first place. All right, number 3, organizational scalability, right? management expects the software output to scale proportionally as the engineering organization scales. In other words, as we add more engineers, we expect the number of features, the bug fixes, the velocity to scale proportionally. However, we know that's not always the case. Adding more people to our code base causes merge conflicts, ownership confusion, duplicated effort, communication overheads. In the worst case, adding more people to the code base could actually slow down the overall engineering velocity. So how does modularity help here? Well, 2 modules, right? Modularity allows engineers to work in parallel. One person works on this module, another person works on this module. They can be independently tested. They can be pushed to main, and those engineers can move on to other tasks in the same or different modules. And this is actually the main reason microservices have become so popular, right? Because with microservices, engineers can work on them in parallel. Now, microservices are really complex. There's a lot of additional code and additional checks and error checking that needs to be done. But the organizational scalability, the fact that you can have 100 engineers working on 100 different microservices, like that parallel benefit outweighs the added complexity of microservices. All right, number 4, faster onboarding. When new developers join the team, the engineering velocity often dips. Why? Because the senior developers need to help with onboarding, explain things. Things slow down a little bit. But with modules, because they're small and can fit in your head without having to understand all the other parts of the system, new developers can, focus on a couple modules and can quickly contribute to those initial modules that they understand. And this simplicity of the code base means fewer distractions and less hand-holding for senior staff. So the senior staff can themselves maintain their velocity and not be slowed down by the new joinees as much. 5, flexibility. So modularity gives the business more options for products' future directions, since small modules are more straightforward to modify and replace with new functionality. Modularity allows engineers to experiment with newer or potentially better approaches, right? When you're creating a new module, you could change a few things. You don't have to necessarily follow the exact pattern of all your other modules. And how do we improve? We have to improve with experiment. We have a hypothesis. We want to try something out. We try it out in a new module, and then we see if it improves the situation. One simple example is, for example, you might want to try a different library. In our case, I wanted to try a different JSON library in one of our modules. And so, I was able to do that because that module was separate from the rest of the code. However, engineering management would not even consider such a library change in a completely monolithic code base where you have to change the library for everyone, since that would pose too much risk for existing functionality. And the last one, number 6, right? Professional growth for software engineers, right? And this specifically addresses engineers who have been with the company for years and are comfortable, or at least used to, the current kind of monolithic approach. The fact is, modular software architectures are becoming the norm in the software industry. And building and maintaining a genuinely modular code base provides valuable experience that engineers can carry to future projects, whether it's in the same company or beyond the current company. If we interviewed a candidate whose preferred working style was to minimize the number of modules in the code base, that would be a serious red flag. All right, so let's summarize the 6 business benefits, right? Faster development and easier maintenance, risk reduction, organizational scalability, people working in parallel, faster onboarding, flexibility for the business, and then professional growth for existing engineers. Now it's great to talk about the benefits. Let's mention a few downsides of a modular code base. The main downside we see is kind of this initial module creation, right? So creating a new module requires defining its interface, how it's going to talk to other modules, directory structure, where to put the code, and writing a new test harness, because the test harness is going to be independent, so you can't just reuse the same test harness. Although you could have some common logic for test harnesses. So these steps require more upfront work than simply dumping the code into an existing package. And this actually downside is fairly large, right? If you are, if you want to take a monolithic approach to a modular one, this first module is going to be really hard because, it hasn't been done before. So you have to figure everything out on your own, and you make mistakes, and you're going to get pushback from existing engineers, maybe your management as well. Yeah, so that's a fairly good downside. Number 2, CI complexity. Ideally, we can compile and test modules independently. And to maximize the development speed, ideally each one can have its own continuous integration run. But as the number of modules grows, being able to manage all of them can become complicated. Like specifically what I'm talking about is you're working on your module, you're making changes just to one module. You want to check in your code, and you just want to focus on whether your module passed a continuous integration, because all your changes are just in that one module and none of them leak outside the module. However, the build is currently bad because something else happened somewhere else in the company and it's failing. So ideally, you would be able to sign off on your changes because your changes are independent of those other failures that are going on, right? And this is related to scalability of the organization, right? An engineer should be able to move forward because their changes are independent of other issues in the company. So the downside here is this managing this independency, making sure things are actually independent, and you can definitely say that my changes are independent of someone else's. Having those clear boundaries in your CI pipeline, that's the challenge. All right, number 3. So some features, security, auditing, maybe logging, things like that, can affect multiple modules. In this case, you want to be consistent between modules, right? You want to keep modules independent, but you want them to be consistent for these cross-cutting features. So, keeping things independent yet consistent, that can become a little bit trickier. All right, that's it for today.